We start our demonstration by double left click on the cover page Andy say hi to the sun. Next, double left click on the red button on the right hand side and then assemble the equation for the nucleosynthesis of hydrogen 1 into helium 4. We start out with hydrogen, and we need essentially 4 of hydrogen, and it is a hydrogen 1. That means it is a hydrogen that has only 1 proton. So the whole nucleus consists of only 1 proton and nothing else. And as it has only 1 proton, it must have a positive charge of +1. In addition, we need 2 electrons. And now this gets us 1 helium nuclei, and it is a helium 4. That means it has 2 protons. Helium is an element that has 2 protons. In addition, it has 2 neutrons. And as it has 2 protons, its electric charge is 2+. In addition, we get 2 neutrinos and we get 6 photons. This happens with a release of energy of 26 mega electron volt. We can also show the same but with symbols, like this is a proton and we need 4 of those, and you see the proton P+ is the same as if you say hydrogen 1 is the same as 1 proton. We need 2 electrons and that gets us 4 hydrogen 2. This is a nucleus that has 2 protons and 2 neutrons. In addition, we get 2 neutrinos and a total of 6 photons. It is quite amazing that you have on the left-hand side 4 protons and 2 electrons, and on the right-hand side you have only 2 protons but 2 neutrons. And then on the right-hand side you have no electrons, but you have neutrinos and photons. And as a scientist, you need to explain how one can get from 4 protons and 2 electrons to what you see on the right-hand side of this equation. Let us show it by taking everything out on the right-hand side, and then just starting from the left-hand side, we should end up with what we took out on the right-hand side. So we start out with 4 protons and 2 electrons, and when we are done, we should have 1 helium nucleus, 2 neutrinos, and 6 photons. Right click and make it disappear. First, we have to create an environment that is like the nucleus, like the core of the sun. That is a temperature of over 16 million degrees Kelvin and an atmosphere that is 10 billion of what we have, times of what we have here on Earth. Because of the very high temperature and the high pressure, the electrons, the protons, which have equal charges that normally repel each other, are pushed very close together, and while they are crashing into each other, one proton transforms itself into a neutron, a neutrino, and a positron. And that happens twice. Then these, so we may simplify this step a little bit, but through the pressure they are pushed closer together into one nucleus, and now we have a helium-4 nucleus. This is a helium-4 nucleus. During that high temperature and high pressure, the protons, I have to be precise, the positron, this is a positron, this is not a proton, I misspoke. This positron and electron annihilate each other and become into photons. And that is the same here. And I have to say, when the helium nuclei is created, 2 photons are also emitted. Now you have a helium nucleus, helium-4 nucleus, you have 2 neutrinos, and you have 6 photons. I think one of the most amazing phenomenon was the annihilation of an electron and a positron. And we know that an electron and a positron have the same mass. You can see that here. The electron and positron have the same mass, but the electron has a negative electric charge of -1e, and the positron has a positive charge of 1e. And when they annihilate each other, we get a photon. Now a photon, look that up here, is a particle that has no charge and no mass, but energy. Let us look at that again. Here you have the equation, an positron, an electron becomes 2 photons. This is an annihilation of a matter and an antimatter, that they have both mass, into a massless energy particle, which is a photon. Here is the famous Feynman diagram of an electron-positron annihilation. Here you have the electron, which is matter, and you have a positron, which is antimatter, and both have mass, and they collide and they become photons. Let's go back to our original equation. For hydrogen 1 plus 2 electrons, 1 helium-4 plus 2 neutrinos plus 6 photons, and energy released, and the energy is released mostly in the form of photons. Now we want to answer the question, is there a difference between mass that we put into the system and the mass that we get out of this system. Is the mass on the left-hand side of this equation the same as the mass on the right-hand side of the equation, or is the mass different? To answer this question, we double left-click on the blue button mass, and we call this the mass input, what we put in, and this is the mass output. And we know that we put in 4 hydrogen 1 nuclei, which is the same as 1 proton, and we know that each proton has a mass of 1.6726 multiplied by 10 to the power of minus 27 kilogram. So this we put in 4 times. 1, 2, 3, 4. In addition, we put in electrons, 2 of those. The mass we get out of this equation is a helium nuclei, helium-4 nucleus, which has a mass of 6.6466 multiplied by 10 to the power of minus 27 kilogram. This is a number we have to look up. And of course, we have the mass of 2 neutrinos, and we have the mass of a total of 6 photons, and that all together gives us the mass of the output mass. Now stop the video and calculate the mass output minus the mass input. You can also double left click on this button and the calculation is shown to you, and the difference is minus 0.0456. We double left click the do it button and we put in 0.0456. And we have to put a minus sign before it, because the input mass is larger than the output mass. So what happened to the mass difference of 0.0456 multiplied by 10 to the power of minus 27 kilogram? To answer this question, we need the help of a very, very great man, Einstein to the rescue. You know, Einstein is most famous for the equation E equals mc squared. For m, you have to put into this equation minus 0.0456 multiplied by 10 to the power of minus 27 kilogram. Of course, you know that c is the speed of light, which is equal to 3 multiplied by 10 to the power of 8 meter per second. And please do not confuse this m for mass with this m in square bracket for meter. This is a unit and this is mass. Now you have to know what the value of c square is, and also what the unit of c square is. The answer is c square is equal to 9 multiplied by 10 to the power of 16, and the unit for this is meter squared divided by second squared. Now just apply Einstein's famous equation, E equals mc square. That means multiply minus 0.0456 multiplied by 10 to the power of minus 27 kilogram by c squared, which is 9 multiplied by 10 to the power of 16, and the units is meter square second square. So just use your calculator or do it in your head and give me an answer. So this is the result. E equals minus 0.04104 multiplied by 10 to the power of minus 11, and the unit is kilogram meter squared divided by second squared. And as it is very inconvenient always to say kilogram meter squared second squared divided by second squared, we just define a new unit that is called the joule and abbreviated with a J. But that stands for kilogram meter squared divided by second squared. And as it has a negative sign, minus 0.04104 multiplied by 10 to the power of minus 11 joule, that means that energy is released, and the energy is released in the form of photons and neutrinos. There is one more step which you have to make, is to transform the joule into electron volt, and you multiply the joules by 6.24 multiplied by 10 to the power of 18, and then you transform the electron volt into mega electron volt by dividing the electron volt by 10 to the power of 6. I think you should be very proud of yourself that you were able to precisely apply Einstein's famous equation E equals mc square, which tells you what energy is generated when the mass is transformed into energy. Thank you for your attention.